Good morning. My name is Nilumesh Kulkarni and this is my co-team member Himanshi Rupesh Godpagi. We are the students of Burst International School and today we are going to present an investigation-based study on the topic Advent of Analog Computing for AI Development. So basically first I would like to explain why analog computing can be necessary for AI developments in the future. Digital systems or von Neumann systems are approaching their limits by today. Moore's law states such so still. So before going into the benefits of analog computing for AI development, I would like to explain basic working principles for that. Now, everything computed in analog starts with setting up differential equations, which involves weights, biases, and configurations being set up in a file. In memory processing. Now, one of the advantages of analog computing is that when you are sending data, it's processed continuously and doesn't require access to external memory, which digital systems almost always require. Storing. Now, these analog signals are time to time stored in digital domain to refetch later for convenience, ease, and a foolproof storage of the signals. After refetching the signals, they are again converted into the digital domain for display. Here, the output is relatively fast, accurate, and overall consumes less power. Now, I would like to present some marginal benefits of analog computing. First is their efficiency. They are highly efficient. As we can see here, there is a comparison between digital analog NPUs and a GPU. The carbon emission or footprints released by them per hour is displayed here. A GPU releases up to 1.5 kilograms of carbon per hour as it consumes almost 300 watts of power. While on the other hand, the digital NPU, though less, still works at around 20 watts to 50 watts range. These still give up to 250 grams of carbon emissions per hour, while an analog NPU, it gives less than that, almost 150 grams for 3 to 4 watts of power consumed per hour. Another advantage is their speed. Now, these AI chipsets are measured in a measurement unit known as TOPS, tera operations per second. A digital NPU offers well around 20 to 40 TOPS at low power and 40 to 100 TOPS at high power loads, almost 70 watts and above. For bare minimum of 50 TOPS, a GPU barely gives any TOPS while still consuming 300 watts of power. But an analog NPU can provide up to 45 watts from 3 to 4 watts at an industrial scale and can go over 100 tera operations per second for 75 watts workload. Now, the last thing I would like to mention benefits is their cost effectiveness. They are very cost efficient. The GPU goes above thousands of dollars, but an analog NPU goes around the same as a digital NPU, still offering more benefits. Where can these things be integrated? Consumer grade electronics such as laptops and smartphones, integration of smart appliances and accessibility appliances, large data centers, even business utilities and government utilities such as traffic signals or security cameras, etc. They can even be used for workhouse stock management. And their advantage, low power consumption and cheaper integration. Most of them are even compatible with the common mSATA and mPCIe Express connections. Now, what are the SDG goals satisfied by our project? The SDG goals satisfied in nomenclature 7, 8, 9, 4, 11, 12, 13 and 15. Last thing I would like to talk is common misconceptions. Many people think that analog computers have latency, but these are extremely quick, even not limited by the digital clocks which digital NPUs are limited to. Second is noise. They think they are clunky and very noisy, but these are not noisy at all. They work with analog electrical signals instead of analog mechanisms. The third is form factor. they think analog computers are huge, but in fact, a 2 by 3 centimeter chip can hold almost up to 8 million weights for an AI processing unit. At last, I would like to ask my friend to continue the rest.
So here are some reference that we have taken for making this PPT. So the photonic analog computing that is made by James M.G. in 2024, the neuroformic computing and application by Hitesh D, Yash G, etc. in 2021, and new computation via neural networks by Howard T.S. Ada Wardle D in 1993. So, analog computing holds to hold immense potentially in AI development. It offers benefits in terms of cost effectiveness, efficiency, and speed. As we continue to push the boundaries of AI development, where it also helps us in achieving our goal and more efficiently. Thank you. Thank you.